Welcome to everyone. Now we move on to the next topic of organic chemistry is aldehyde, ketones and carboxylic acid. Dear friends, the weightage of this chapter is 8 mark, which carries 3 questions in annual examination. Question number 9, 1 mark. Question number 16, 2 mark. Question number 34 having 5 marks in mark A, B, C. There are 3 sub questions in question number 34. Totally the weightage 8 marks in the chapter aldehyde, ketone and carboxylic acid. Basically friends, all 3 components of this chapter is completely depend upon carbonyl carbon. Carbonyl carbon having a wide application in our biological science and biochemistry part. So this carbonyl carbon which helps to sustain our life. And this carbonyl carbon compounds in our syllabus is a functional group of RCHO is your aldehyde. Similarly is RC double bond O, R is nothing but is a ketone. Similarly to the RC double bond O, OH, this is your carboxylic acid. And similarly RC double bond OO, this is your ester, and RC double bond O NH2, I think all of you know this is your amine. All these components having one similarity is where carbonyl carbon. This is your carbonyl carbon, carbonyl carbon. So it means carbonyl carbon is a major role in organic chemistry. Already we know it helps to sustain our life. So this carbonyl carbon in all these cases which is having an sp2 hybridization friends. Carbonyl carbon which having sp2 hybridization involving 3 sigma bonds and 1 pi bond. I repeat, carbonyl carbon having sp2 hybridization of a carbon with 3 sigma and 1 pi bond. Yes, in this category we have 3 subunits, aldehyde, ketone and carboxylic acid. Today we continue this part of the syllabus by one by the aldehyde, ketone as well as our carboxylic acid. Okay, so friends, aldehyde, basically we start this chapter is aldehyde. We know the general formula is RC double bond O H. R stands for alkyl or aryl groups, means aliphatic or either aromatic groups which is having this R representation. So aldehyde is a major which is available or which is the source of carboxylic acid. Aldehydes are the source of the carboxylic acid. The last letter, this is IC acid or either OIC acid. IC acid or either OIC acid of a carboxylic acid is replaced by the term is aldehyde. The term aldehyde. Yes, aldehydes are derived from the carboxylic acid. In the carboxylic acid, OIC acid is replaced the term aldehyde. Now you can get your corresponding alkyl. You can use aliphatic alkyl aldehyde or either aryl aldehyde. This is the simple story behind your aldehyde. I repeat, aldehydes are also the one of the carbonyl carbon compounds with the general formula RCHO. R stands for either alkyl or either aryl groups. Yes, these aldehydes are derived from the carboxylic acids, means the carboxylic acids containing OIC acid is which is replaced by an aldehyde returned as alkyl aldehyde or either aryl aldehyde. This is the simple story of aldehyde. In similarly to the ketones, ketones are derived from any alkyl or aryl groups. And repeat friends, when ketones are derived from any alkyl or aryl groups with the general formula RC double bond O. This R represents either alkyl or either aryl groups. This is a simple introduction regarding the aldehydes as well as ketones. You keep in your mind, ketone is the general formula RC double bond OR, and aldehyde which having RCH2. So both alkyl or aryl group you can substitute in the position of R. This is a simple introduction part of your corresponding aldehydes and ketones. And now we want the nomenclature of these aldehydes. Okay, in nomenclature, the aldehydes, because they are derived from the corresponding carboxylic acid groups. Very simple. They start with an aldehyde. Commonly already we know, friends, the components we pronounce as an alkyl aldehyde or either derived from the carboxylic acid. We have a very simple example as mentioned in our syllabus, HCOOH. And this HCOOH is an acid we call is an formic acid. HCOOH is called formic acid, and this formic acid is formica is nothing but is a red ants in English. The formica is a Greek word. In English we use a red ants, and by grinding this red ants you can get this formic acid with the formula HCOOH. Friends, so already we know the aldehydes are derived from the carboxylic acid. The formula of the first is simple, HCH2, because CH2 is the functional group of aldehyde. I repeat, CH2 is the functional group of aldehyde. As they are derived from the carboxylic acid, formic acid, already we know they replace OIC acid or IC acid by aldehyde. The name of this compound formaldehyde. Name of this compound formaldehyde, because it is formic acid derivative. Similarly to the second one, CH3COOH. This compound is acetic acid. They derive from vinegar, is a plant. Sir, this acetic acid, IC acid, is replaced with an aldehyde, is a CH3CHO. Now the term is acetaldehyde. Acetaldehyde. Similarly, propanaldehyde, butyraldehyde. So the nomenclature is carried out based on the carboxylic acid. This similarly to your ketones also. Better first, with friends, you know the completion of your aldehyde part of the nomenclature. Yes, how can you nomenclature? Yes, this is your formula, common name, and IUPAC. So let us begin with the first simplest aldehyde of our syllabus, is with the formula HCH2. HCH2, they contain one carbon because it is derived from formic acid. The common name of this compound formaldehyde. Name of this compound formaldehyde. It contains only one carbon atom because the one carbon is a methane. Yes, we have the term methane, METHANE, methane. The last letter E. The last letter E is replaced by the term, is a suffix is AL, friends. Term suffix AL we pronounce is methanol. Means in aldehyde, in IUPAC, E is replaced by AL. You keep in your mind in your IUPAC nomenclature. Similarly, you have to consider the second example is the CH3CH2. CH3CH2. Sir, this is derived from acetic acid. That's why we call it acetaldehyde. They derived from acetic acid, so we call it acetaldehyde, which contains two carbon. As you know here, ethane, ETHANE. E is replaced by EL. Now the term is ethane. Similarly, we have to gradually increase the carbon of CH3CH2, CHO. I think all of you know it is derived from propionic acid, so propanaldehyde. Can you agree with me? They containing 3 carbon, propene is replaced. Now the term is propanol. Propanol. And now we have CH3, CH2, CH2, CH2. How many carbons? 4. There are from butyric acid. Name of this compound is butyraldehyde. Butaraldehyde. Butyraldehyde. 4 carbon. There are from butane. So the name of this compound is butane. This is a simple nomenclature part of aliphatic aldehyde in our syllabus, friends. Is HCHO is called methanol, CH3CHO is called ethanol, and CH3CH2CHO is called propanol, and CH3CH2CH2CHO, the 4 carbon is called butanol. This is a very important part of our syllabus. As your CET question or competitive exam, I have a simple question. CH3 twice, the CH. Yes. What about the IUPAC name of this compound? First, you have to write the skeleton structure. This is a CH and the functional group attached CHO. 2CH3. This is the 2-methyl groups. This is skeletal structure of this one. Sir, in this case, we have 1, 2, 3 position. The functional group aldehyde is attached with the symmetric carbon. We use the word is iso. How many carbons? 4. Iso butyraldehyde. Iso butyraldehyde is the name of this compound. What about IUPAC? I think all of you know this is the second position. This is the carbon number 1, 2, 3. 1, 2, 3. Yes, it is your prefix. Prefix is a methyl. So we call the second position name of this compound 2-methyl. What it remains? 3 carbon is remains. 2-methyl 1-propanol is the nomenclature of this competitive question of isobutyraldehyde. Since this is simple story regarding the nomenclature of your aldehyde. Yes, as similar to the aldehyde, we want the ketone also, friends. How ketones are named in our syllabus. A very interesting part of the nomenclature, aldehydes as well as ketones. Yes, carefully you have to practice with the different examples mentioned in our NCERT textbooks or either examplers. Yes, now we have a target to ketones. Already we know ketones are derived from the corresponding alkyl or aryl groups. I repeat, ketones are derived from the corresponding alkyl or aryl groups. With the general formula, I have to mention RC double bond OR. If both are same, or either RC double bond O R dash. One is alkyl and aryl, or either different alkyl groups. This is a very simple general formula of the ketone category. Sir, how can you name this compound? With same column, this is the formula. Common name. The next one is your corresponding IUPAC. Yes, this is a simple story of this syllabus, friends. The simplest ketone mentioned in our syllabus is with 2-methyl groups. 2-methyl group is attached to the carbonyl carbon. The methyl is a 2 same. The name of this compound dimethyl ketone. Name of this compound dimethyl ketone. Yes, in IUPAC, we have to mention the carbon numbers 3. Yes, the ketone is at the second position. So, how to mention the IUPAC? IUPAC, very simple, the alkane. The last letter E. In alkane, the last letter E is replaced by the suffix is ONE, not 1. It is replaced by ONE. The term, the compound alkanone. Yes, this is the IUPAC name of ketone. What about aldehyde? Alkanol. Alkanol is aldehyde. Alkanone is a ketone. Based on this, we have 3 carbon friends. Is the 3 means of pro at the position is 2. So the nomenclature of this compound 2-propanone. 2-propanone. I repeat, in a ketone, they are derived from alkyl aryl groups. They based on alkyl group we mention in common system, but in IUPAC, which is depend on alkane, the last letter E is replaced by the term suffix is ONE. Now the total IUPAC nomenclature is alkanone is like 2-propanone. Now I have to use, this is a C2H point and C double bond O, C2H. Now use symmetric to ethyl groups to mean same diethyl ketone. Diethyl ketone. This diethyl ketone which consists of totally how many carbons? 2, 3, 5. So 5 means pentanone. At the position of the carbon is 3 because already 2. This is a 3 and this is a 5. Third position is carbonyl carbon. So total carbons are 5. The name of this compound is 3. 5 means this is 2, 3, 5. So 5 means pentanone. 3-pentanone is the name of this compound. Now it is another one. First, now I have to mention in our part CH. This is asymmetric. Based on alphabet here, friends, this is the ethyl, this is the methyl ketone. Based on alphabet, we have to mention ethyl, methyl ketone. Total number of carbons are 4. So, numbering from the nearest carbon, carbon number 1, number 2, number 4. A second position, number is first 2. Total numbers are 4. 4 means butanone. This is your nomenclature part of the ketone. So 2-propanone. Yes, this is your 3-pentanone, and this one is and 2. So you keep in your mind this one. It's very important. Dimethyl ketone or either 2-propanone. Commercially use the word is called acetone. Keep yourself. The name of this compound is acetone in your nomenclature part. This is the simple story of today's part. Is aldehydes and ketones. Both are the carbonyl carbon compounds, and they derived from aldehydes derived from carboxylic acids. Ketones derived from an alkyl and aryl groups. Friends, keep yourself the final part. Aldehydes, IUPAC nomenclature is known as aldehyde, especially aldehyde. Alkanal. Keep on. Alkanal. But in ketone, alkanone. Aldehyde alkanal ಆಗುತ್ತೆ, ketone ಅಲ್ಲಿ alkanone ಆಗ್ತದೆ. Practice ಮಾಡಿಪ್ಪ. So this is very important of your syllabus. Today I wind up here, and then the next in the video we move on to the methods for the preparation. Thank you. Welcome to everyone. Now we move on to the topic aldehydes. In that part, we'll start the methods for preparation. How to prepare aldehydes by using different name reaction. Friends, keep in your mind, in this syllabus, means PUC second year syllabus, we have 4 name reactions. The first one, Stephen's reduction reaction, Rosenmann's reduction reaction, Yettard reaction, and the last one, Gattermann-Koch reaction. Let us begin with the first important reaction of our syllabus, is a Stephen's reduction reaction. In this reaction, we use the reagent is a tin chloride with concentrated HCl. You keep in your mind, tin chloride with concentrated HCl or stannous chloride with concentrated HCl, because it is 1 mark question for the question number 9. Let's start. Stephen's reduction reaction. How to form aldehyde? This by using an nitriles. Nitriles are nothing but cyanides. You keep in your mind, already we know nitriles and cyanides. So how to prepare, friends? RC triple bond N. This is your corresponding alkyl cyanide. When this alkyl cyanide is strongly treated with your tin chloride SnCl2 in presence of concentrated HCl. Tin chloride with concentrated HCl to generate the nascent hydrogen. If you want this reaction, you keep yourself SnCl2 is react with 2 moles of HCl to form the product SnCl4 and to generate 2 nascent hydrogen. This is the simple part how to generate nascent hydrogen by using tin chloride. Okay friends, I repeat, when alkyl cyanide is react with tin chloride, they generate 2 moles of nascent hydrogen. Once the reaction starts, the formation of the compound is R as it is alkyl. This is C attacking with 1 carbon. The triple bond is converted into double bonds. We have another one, and this is your H. Or CH, double bond in H, with the acid will come out as a salt. The name of this compound is imine, I-M-I-N. Keep yourself. Means alkyl cyanide undergoes simple reduction. Our product is imine, but our target is aldehyde. What happens when this imine undergoes acid hydrolysis? I think all of you know this CH plus and OH plus. Once it reacts with an acid hydrolysis, you keep in your mind, sir, R, this is a CH and this O. This oxygen is combined with this carbon. What about your compound? Is RCHO. Yes, our target is finished. Is aldehyde. So what it remains? That's very important. It remains, friends, nitrogen, 1 hydrogen, second hydrogen, third and fourth hydrogen with Cl. Means 1 nitrogen, 4 hydrogen with Cl. The formula salt is ammonium chloride. Start carefully. When alkyl cyanide undergoes reduction with tin chloride and concentrated HCl to form the product is imine, which undergoes acid hydrolysis to form our target is aldehyde. Yes, we have an example, friends. To keep in your mind is a CH3C double bond. Yes, 2 carbon atoms. The name of this compound, methyl cyanide. Nitride, so a wonderful name, ethane nitride, ETHANS ethane nitride. Yes. When this ethane nitride is undergoes the same reduction, they generate 2 nascent hydrogen. The cleavage of this pi bond, CH3CH, this is CH3CH double bond. So what about the name of this compound? Acid. This is acetaldehyde derivative. And based on this acetaldehyde derivative, yes, this is acetaldimine. AST D-I-M-I, acetaldimine hydrochloride. Acetaldimine hydrochloride. You can use imine hydrochloride also. This is imine hydrochloride because it is in the form of salt. Acetaldehyde or acetaldimine hydrochloride. And then I think all of you know, yes, which undergoes acid hydrolysis H plus and OH. Yes, you can yourself you have to try CH3C, CH and this oxygen. The name of this compound is CH3 CHO. Already know this is your 2 carbon acetaldehyde. What about IPAC? 2 carbon ethane, end up with Al, ethanol, with 1 nitrogen, 1, 2, 3. Yes, and your component which is available in syllabus, which having is NH4Cl will be formed. Yes, in your imine character. Yes, you can use this acid chloride also to mention the salt here. This one. This methyl cyanide is undergoes reduction reaction to form acetaldimine hydrochloride similar to here, and then 1 nitrogen, 1, 2, 3, 4 hydrogen with Cl. This is where ammonium chloride. This is the first reduction reaction of our syllabus. Stephen's reduction reaction with reagent tin chloride with concentrated HCl with different examples. You have to practice with different examples, friends. Methyl cyanide, ethyl cyanide, propyl cyanide. You can get it. The intermediates are imines and finally corresponding aldehydes. This is your first reduction reaction of syllabus is Stephen's reduction reaction. Yes, after this Stephen's reduction reaction, we move on to the second reaction of our syllabus. Yes, so many simple methods are mentioned in our aldehyde chapter, how to prepare different aldehydes with a different reaction. I have taken a very simple example, direct reaction in our syllabus as mentioned is Aldehyde reaction. So many times they ask this question, friends, in the JEE and competitive exam, which is the reagent used in Aldehyde. The name of is CrO2Cl2. CrO2Cl2. Name of this compound bromine. Bromine chloride. So name of this compound bromine chloride gas. This is bromine chloride. This is coming from the derivative of your potassium dichromate and concentrated HCl and the any halide salts. They generate this gas bromine chloride. Keep in your mind the formula CrO2Cl2. But in competitive, friends, we ask like this: CrO2Cl2, Cr2O2Cl2, CrOCl, Cr2OCl2. Among these four, which is the correct answer for bromine chloride gas? I think all of you keep in your mind the first one is the correct answer, CrO2Cl2. These are the different options they provided in the competitive examination. Just don't bother about that reaction. Yes, how to prepare aldehydes from Aldehyde. Very wonderful, simplest reaction. Yes, friends, I think all of you know this is your chemistry. Name of this compound, methylbenzene, or another name, toluene. When toluene undergoes reaction with a gas is a bromine chloride. Yes, in presence of an organic solvent, carbon disulfide, followed by acid hydrolysis. I repeat, when toluene reacts with bromine chloride, this is your bromine chloride, in presence of carbon disulfide and followed by hydrolysis to form the product is CH. Name of this compound, benzaldehyde. Benzaldehyde, or either IPAC, benzene carbaldehyde also. Yes, what about the IPAC name? Benzene carbaldehyde or either benzaldehyde. This is a simple Aldehyde reaction. I repeat once again, Aldehyde reaction, and in the reagent bromine chloride, CrO2Cl2. Here, toluene undergoes react with bromine chloride gas in presence of carbon disulfide and acid hydrolysis to form benzaldehyde. Yes, today we have two reactions, one Stephen's and another one is Aldehyde reaction. Keep practicing, friends, and in the next video we continue Rosenmund and Gattermann post reaction. Thank you. Yes, welcome to everyone. Now we move on to the very important reaction of the chapter, aldehyde, Rosenmund's reduction reaction. Yes, they asked so many times for the 1 mark question, friends. What are the reagents used in Rosenmund's? You keep in your mind, palladium in presence of barium sulfate with an solvent is xylene. PD bar BaSO4 xylene. Keep in your mind is a PD, palladium. You don't use PB. PB means lead. Keep yourself as a palladium. Yes, how to prepare this Rosenmund reduction reaction? Yes, let us begin, friends, by using your RCOCl. What is RCOCl? It is called acid chloride. Corresponding acid chloride. When acid chloride undergoes reaction with palladium in presence of barium sulfate with a solvent is xylene, they generate an molecular hydrogen. And this hydrogen is undergoes homolysis. This is H and H. It undergoes homolysis. One H is combined with electronegative of the Cl To release the product is an HCl. To release the product is HCl. What it remains here RCO and 1H. The product is RCHO. Now our target is finished. This is your aldehyde. I repeat friends, in Rosenman reduction reaction, when acetic chloride undergoes treated with a palladium in presence of barium sulfate to generate a molecular hydrogen which itself is undergoes homolysis, the release of hydrochloric acid and aldehyde. Yes, we consider an example as mentioned in our syllabus is CH3 C double bond O. Already we familiar. Yes, this is called acetyl chloride. This is acetic acid derivative, acetyl chloride. When acetyl chloride undergoes reduction with same palladium, yes, we know this hydrogen is H and H, and this Cl is comes to here. The formation of the compound is HCl. What it remains? CH3CO and 1H. This is a CH3 CHO with the 2 carbons is acetaldehyde. Acetaldehyde. What about IUPAC with 2 carbon? Yes, ethane null. Yes, I repeat once again, acetaldehyde undergoes reduction with Rosenmann's to form the product is ethanol. Similarly, as increase in carbon number, you can get into different aldehyde. As important to our theory examination, question number 9. So many times ask this question, complete the reaction. So how to complete this reaction? First, you keep in your mind the name of this compound. Yes, this is C6H5. This is a C double bond O. This is your C. Name of this compound is benzoyl. BNZOY. Benzoyl chloride. Benzoyl chloride is the derivative of benzoic acid. Benzoic acid in the yes, this is benzoyl chloride. Sir, benzoyl chloride undergoes the same reduction reaction with Rosenmann. They generate hydrogen, and this Cl is combined with H to form the product as it is HCl. What it remains? C6H5 benzene, and this is a CO and 1H. The name of this compound benzene, and this is a CH. Yes, this is your benzaldehyde. I repeat friends, when benzoyl chloride undergoes Rosenmann reduction reaction to form the product is benzaldehyde. Yes, the reagent to keep in your mind, the practice palladium with barium sulfate in presence of benzaldehyde. And this is a Rosenmann's reduction reaction to prepare aldehyde. Yes, by using different components. Yes, as mentioned in our syllabus. Same question I have to mention like this. This is also important. Friends, you keep in your mind C6H5 COCl. Don't bother. This is 7 carbon atoms. We call it heptide. No, it is aromatic. His name of this compound is benzoyl chloride. Yes, benzoyl chloride is undergoes reduction with the same palladium in presence of barium sulfate with xylene to release the product as already know HCl, and what it remains C6H5 CO and 1H. This is C6H5 CH2. Name of this compound is benzaldehyde. It's a very important reaction of this chapter, Rosenmann's reduction reaction. I repeat once again, friends, in the preparation of different aldehydes, both aliphatic and aromatics, you can easy to prepare by using Rosenmann reagent. Name palladium and barium sulfate in presence of xylene by using acid chloride. Keep in your mind, Rosenmann reaction by using acid chlorides can prepare different aldehydes as mentioned in our syllabus. As apart from this, we move on to the next video. We have a wonderful reaction is Guttermann's Koch reaction. Thank you. Welcome to everyone. Now we move on to the last reaction of the method for preparation of aldehydes. The name of the reaction, Gattermann-Koch reaction. Friends, we already know the three reactions. One is a Stephen's reduction reaction using tin chloride with concentrated HCl. Ettard reaction by using chromyl chloride. Third one, yes, that is Rosenmann's reduction reaction, palladium and ions of barium sulfate with xylene. Now we have, carefully remember, Gattermann's Koch reaction. The reagents for this reaction, carbon monoxide in presence of concentrated HCl with the catalyst anhydrous aluminum chloride with cuprous chloride. Keep in your mind, cuprous chloride. This what happens is when this Gattermann-Koch reaction is helpful for preparation of the aromatic aldehydes, like example benzaldehyde or either some substituted benzaldehydes we can easy to prepare by Gattermann-Koch reaction as similarly Ettard. Now we have started with this reaction when benzene reacts with a component is carbon monoxide. Reacts with a component is carbon monoxide in presence of concentrated HCl with anhydrous aluminum chloride with cuprous chloride. Cuprous chloride, yes, all in benzene, all 6 delocalized hydrogens will be takes place. They can easy to cleavage. Now the formation of the product is benzene. This is NaCH. A very simple reaction. When benzene reacts with carbon monoxide with this reagent, the delocalization of one hydrogen can easily attack into the carbonyl carbon. The formation of the product is benzaldehyde or either another name benzene carbaldehyde. I repeat, benzene react with Gattermann reagent to form benzaldehyde. To keep practicing for this reagent is very important, friends. Carbon monoxide, concentrated HCl, anhydrous aluminum chloride, and the another one is cuprous chloride to form our component. It's a simple method for preparation of our syllabus is benzaldehyde. Yes, after this fourth preparation, let us move on to the next category of this chapter is corresponding physical properties. What are the physical properties of your corresponding aldehydes? This is physical properties. Yes. We have so many physical properties regarding to the aldehydes and ketones, friends. I mentioned some of them. They are very simple. The first one in our syllabus, I think all of you know, is methanol. Methanol, I think all of you know formula HCH. Methanol is available in the form of gas at room temperature. I repeat, friends, methanol, formaldehyde or HCHO is a gas at room temperature. This is the first physical property of our syllabus. And second one is ethanol. You keep in your mind formula CH3CHO. Another name acetaldehyde is volatile. Volatile liquid. So ethanol or acetaldehyde is a volatile liquid. This is the second one. If you want the third category, as higher aldehydes. Higher aldehydes means apart from methanol and ethanol, propanol onwards, they are available liquids or either solids. It means aldehydes are available in three forms: gas, liquid and solid. And this is the first physical character of our aldehyde. And then apart from this, now we come to the second category. Yes, aldehydes, I think all of you know this is a functional group, this CHO. As ketone is a C double bond. Both this carbonyl carbon compound, aldehyde and ketones, are having higher boiling point. Aldehydes and ketones are having higher boiling point compared with corresponding hydrocarbon or ಈಥರ್ಸ್. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ, ಆಲ್ಡಿಹೈಡ್ ಕೀಟೋನ್ಗಳು ಹೈಡ್ರೋಕಾರ್ಬನ್ ಮತ್ತು ಈಥರ್ಗಳಿಗಿಂತ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಯಾಕೆ ಸರ್? ವೈ ಇಟ್ ಈಸ್ ಅವೈಲೇಬಲ್ ಇನ್ ದಿಸ್ ಕಂಪೋನೆಂಟ್? ಬಿಕಾಸ್ the component is having weakly molecular association friends. Due to the weakly molecular association, aldehydes and ketones are having little higher boiling points. This is the second category. Third one, aldehydes and ketones. Yes, better I have mentioned. Aldehyde is Al, ketone is ON. Aldehydes and ketones are miscible in water, especially lower aldehydes or lower ketones. Lower aldehydes and ketones are easily miscible in water. I think all of you know, due to the hydrogen bonding. Yes, this is due to hydrogen bonding. This is the fourth important property of the aldehydes. And the last one, friends, this lower aldehydes. Lower aldehydes. Like example, formaldehyde, astardiol means methanol and ethanol are having a sharp, pungent odor. You keep in your mind, the lower aldehydes are having sharp, pungent or ghat vasane irutade. These are the four important physical property. I repeat, aldehydes are available in three forms as well as gas, liquid and solids. Methanol is gas at room temperature, ethanol is volatile liquid, higher means propanol, butanol and so on. They are available in the liquid as well as solids. And they are very important. Aldehydes and ketones are having higher boiling point compared with corresponding hydrocarbon and ether. ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟ molecular mass ಮೇಲೆ ನಿಂತಿರ್ತದೆ ಮಕ್ಕಳು. ಎಲ್ಲರಿಗೂ ಗೊತ್ತದ ಸರ್ why it is available? It is due to the important due to molecular mass. The reason is important. Why, sir? The boiling point increases due to the molecular mass. And aldehyde and ketones are means lower aldehydes and lower ketones are miscible in water. They can easily to mix up with water due to the hydrogen bonding. And the last one, lower aldehydes are having sharp pungent odor. Especially keep in your mind is example formic acid and acetic acid. Formic acid ಇಂದ ಬಂದಿರ್ತದೆ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್, ಅಸ್ಟಿಕ್ ಆಸಿಡ್ ಇಂದ ಬಂದಿರ್ತದೆ ಸ್ಟಾಲ್ಡಿಹೈಡ್. ಅರ್ಥ? ಎಸ್, ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಅಂಡ್ ಸ್ಟಾಲ್ಡಿಹೈಡ್ಸ್ ಬೋತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಪಂಜೆಂಟ್ ಓಡರ್. ಪಂಜೆಂಟ್ ಅಂದ್ರೆ ಘಾಟ್ ವಾಸನೆ ಇರುತ್ತದೆ ಸರ್. ಸೊ ದೀಸ್ ಆರ್ ದ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ವಿಚ್ ಕಮ್ ಅಕ್ರಾಸ್ ದ aldehydes in today's video. Thank you. We move on to the chemical properties in the next class. Thank you. Hello everyone. Let us move on to the chemical properties of the chapter aldehydes as well as ketones. In this part we have a major part of the reaction is a condensation reaction. What happens when aldehydes and ketones undergoes condensation with ammonical derivatives? I have to use the word is NH2G. G is any substitutions is the ammonical derivative. These are the ammonical derivatives with general formula NH2G. What happens when aldehydes and ketones undergoes condensation? Well, let us begin with general reaction, friends. And this is your aldehyde RC, double bond O, and this is H. Aldehyde is undergoes reaction with your ammonical derivative as our convenience I mentioned like this NH2G. Yes, when aldehydes is condensed with ammonical derivatives, the condensation will be takes place, friends. The release of an water. To release an water. Yes, what about the condense? This RC. The carbon is condensed with the nitrogen like this. RC. This is H. The C double bond N. This is your H. Yes, the condensed product we call is skip base. We mentioned the name. When aldehydes or either ketones is react with any ammonical derivatives, are ammonical derivatives with the loss of water to form a product is called skip base. It is a general reaction of aldehydes. As similar to the ketones, friends, here's this R, C, this is your R and double bond O. ketone is react with your ammonical derivatives. Here also the loss of water, this is your loss of water, the loss of water. Now the product is RC, this is your R, the carbon nitrogen double bond will be takes place, the C double bond N, this is the G, this is also called skip base. This is a condensed product. I repeat once again, the condensation reaction takes place in aldehyde ketone. Is react with ammonical derivatives like NH2G or NH2X. You can mention any substitution. Yes, the formation of the product with loss of water is skip base. Repeat, aldehyde ketone react with ammonical derivatives with loss of water to form the product involving carbon nitrogen double bonds are called skip base. This is the general mention of condensation reaction in our syllabus. Yes, as mentioned in our syllabus, friends, we have various types of ammonical derivatives in PUC second year syllabus. We have list out first and then we start practicing those ammonical derivatives. What are those? Very simple. The first one in our syllabus is an NH2. G means OH. Name of this compound hydroxylamine. This is the first one. Second one is NH2. Name of this compound hydrazine. Number third C6H5 NH2. Name of this compound phenyl hydrazine. NH2 NH C double bond O NH2. Name of this compound semi-carboxylic. The next one, this is NH2. Already we know this is phenyl hydrazine, this is phenyl hydrazine. Yes, we have a 2 nitro group. A second position and a fourth position. Shortcut, the name of this compound is very important. 2,4-DNP. Complete name 2,4-dinitrophenyl hydrazine. These are 1, 2, 3, 4, 5. These are 5 ammonical derivatives are mentioned in our syllabus 3 condensation reaction. Let us begin, friends, with aldehydes and ketones with corresponding example. Yes, first one, what happens when aldehyde RC double bond O H. This is your aldehyde. What happens when aldehyde is react with NH2OH? As convenience, I write like H2N. This is your H. Name of this compound hydroxylamine. Hydroxylamine to removal of water. Similar in the your general reaction. And removal of water, what it remains? RCH double bond N. This is RCH. This is a double bond N. This is what? The name is very important, friends. We use hydroxylamine and the final product you can use aldehyde oxime. Aldehyde oxime. In shortcut we use aldoxime. ALDOXime. What happens? When aldehyde react with hydroxylamine to form the product is aldehyde oxime or aldoxime. Yes, we can use an example for this. Yes, this is the CH3, C double bond O, CH. You know, this is acetaldehyde. Acetaldehyde. What about the IPAC with 2 carbon? 2 means ethanol. Very good. Ethanol is reacted with H2NOH. You know already, hydroxylamine with the loss of water. This is the loss. The loss of water. This is the loss of water. Yes, now what it forms is CH3 CH double bond N. This is H. Based on this, we can use a name is acetaldehyde oxide. A very simplest name. I repeat, when acetaldehyde reacts with hydroxylamine to form acetaldehyde oxide. This is in the case of aldehyde. What happens in your ketone? What happens in ketone? I mentioned in ketone, friends, R C double bond O. This is your R. You keep in your mind, it is your ketone. When ketone is reacted with H2NOH, the name of this compound, hydroxylamine. Yes, with the loss of water. This is the loss of water. The name of this compound is RC. R as it is. C double bond N. This is H. What about the name of this compound? Ketone oxide. Ketone oxide, or either another name, ketoxide. This is your name of the compound. I repeat, ketone undergoes react with hydroxylamine to form ketone oxide. Yes, I mentioned example here only, friends. So this is your corresponding example is CH3 C double bond O CH3. I think all of you know. Name of this compound is acetone. Acetone undergoes reduction reaction with your hydroxylamine. Yes, to form this water. This is your water. The mentioned loss of water. What it remains? CH3 as it is, and this is CH3, and double bond N. This is your H. What about the name of the compound? This is derived from acetone. This is acetone oxide. Similarly, we can use different ketones. I repeat, ketone undergoes react with hydroxylamine to form ketoxide or ketone oxide, like acetone to form acetone oxide. This is the first condensation reaction by using as our syllabus is hydroxylamine. I repeat, aldehyde or ketone react with hydroxylamines to form either aldoxide or either ketoxide. Yes. Similarly, friends, by using the same concept of hydroxylamine, let us move on to the second example. Is mentioned already in our syllabus is hydrazine. It's a very, very important part. What happens when hydrazine reacts with your aldehyde? Yes, I have to use a general reaction as well as corresponding examples. So, start with your RC double bond O H. Already know? Aldehyde. Is react with hydrazine as convenience H2N and H. Hydrazine spelling in category HYDRA ZI hydrazine with loss of water. Yes, this is the loss of water. What it remains R C. This is your H as it depends on double bond N and H. What is the name of this compound? This is aldehyde derivative. This is aldehyde hydrazines. After condensation, they convert it into hydrazones. ZONE. After condensation, the skip base name is called zone. ONE. Zine converted into zone. I repeat, aldehyde react with hydrazine to form aldehyde hydrazone. Yes, friends, to keep yourself in a practice with example, CH3, C double bond O, this is H. Yes, what is the name of this compound? Is acetaldehyde. Acetaldehyde reacts with hydrazine. This is NH3NH2 hydrazine. Yes, this is a loss of water. Very simple. You have to practice carefully. Loss of water. Yes, now the CH3. C, this is H, double bond N, this is NH2. Can you give me the name of this compound based on this? This is acetaldehyde. Acetaldehyde. Yes, the compound hydrazine is hydrazone. This is acetaldehyde. Hydrazone is, yes, acetaldehyde hydrazone react with hydrazine to form acetaldehyde hydrazone. This is in the case of aldehydes. Yes, can you agree with me? It's a ketone. It's RC double bond O. This is your ketone. Reacts with same H2NH2 hydrazine. Similar reaction. Yes, loss of water. This is the loss of water. Now what it remains RCR double bond NH2. Yes, can you give the name based on here? Yes, this is ketone. What happens? Hydrazone. Very simple. And ketone react with hydrazine to form ketone hydrazone. With example, yes, can you practice? This is your CH3 double bond. Name acetone. Reacts with H2NH2. H2NH2 with loss of water. CH3, CH3, double bond NH2. Condensation is finished. Acetone, hydrazone. Name acetone, hydrazone. This is the second reaction. Which I repeat once again, either aldehyde or either ketone react with hydrazines to form corresponding hydrazone. Just keep in your mind, just replace water. Just replace water, condensation of carbon to the nitrogen with double bond. Hydrazines to the hydrozones. Today we have two condensations. One is hydroxylamine, second one is hydrazine. Just keep practicing with a different example with condensation. Really, very example, acetaldehyde, formaldehyde, propanaldehyde theory. So acetone means 2-propanone. Can use butanone, pentanone. Can use condensation reaction for any aldehydes, either aliphatic or aromatic. And in the next video, we continue the next concepts. Thank you. Yes, welcome to everyone. Now we move on to the next condensation reaction of the aldehydes and ketone chapter. We already come across in the last video condensation of hydrazine and condensation of hydroxylamine. When aldehydes and ketones condense with hydroxylamine to form the product corresponding oxines. Similarly, when aldehydes and ketones react with hydrazines to form the corresponding hydrozones. Let's move on to the next part is condensation with phenylhydrazine. Then formula C6H5 NH2. What happens when this phenylhydrazine is condensed with aldehyde? This is your aldehyde is condensed with, as in my convenience, the formula is NH2, NH. If you want like benzene, better I mention benzene ring here. Name of this compound is a phenylhydrazine. When aldehyde react with phenylhydrazine, already we know when condensation takes place with the loss of water, this is a loss of water. The final product is RC, H as it is. This is a double bond NH with this is C6H5 or either NH. Name of this compound aldehyde phenyl hydrazone. Aldehyde phenyl hydrazone. This is your general reaction. You can practice with an example is acetaldehyde react with phenylhydrazine to form acetaldehyde phenyl hydrazone. Yes, directly I move on to the next one. a general reaction of ketones. You can practice with example. Yes, this is R and double bond O. Yes, this is your ketone. Yes, when ketone is react with the same, the compound is H2NH. This is your benzene. Name phenyl hydrazine. Yes, with the loss of water. This is a loss of water. The loss of water. Now the product is R, C. This is your alkyl R. Double bond N, NH. This is your thermal. Name of this compound ketone phenyl hydrazine. Yes, friends, these two are the general reaction by using aldehyde or ketone. You can practice with an example here. Yes, the formula is very important. This is your CH3, C double bond OH. You can use aldehyde. Here you can use to mention the CH3 double bond O. This is your acetone. The name of this compound acetone phenyl hydrazine. Aldehyde uses to the aldehyde phenyl hydrazine. Similarly, you can practice with the last video reactions. Yes, aldehydes and ketones condense with phenyl hydrazine to form aldehyde phenyl hydrazine and ketone phenyl hydrazine. Yes, and after this reaction, we move on to the next important reaction as mentioned in our syllabus. There is semi-carbazide. So friends, semi-carbazide reaction to the condensation, a very important reaction as compared with theory, is very important for your NEET point of view. Especially your competitive exam, they ask the question, yes, condensation reaction of a semi-carbazide. So why this semi-carbazide is very important? Yes, I mentioned semi-carbazide. Okay. So semi-carbazide, I think all of you know the formula NH2NH C double bond O and H2. The name semi-carbazide. The important question in a competitive exam, in semi-carbazide there are 3 nitrogen atoms. Which nitrogen is undergoes condensation? Either 1 or either 2 or either 3. Andre semi-carbazide alli 3 nitrogen ada condensation alli yava nitrogen ಪಾಲ್ಗೊಳ್ಳುತ್ತೆ? ಇಲ್ಲಿನೂ NH2 ಅದು ಇಲ್ಲಿನೂ NH2 ಅದು. So ಬಹಳ ಜನರು ಆನ್ಸರ್ ಥರ್ಡ್ ನೈಟ್ರೋಜನ್ಸ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಅಥವಾ ಒಂದಿಷ್ಟು ಹುಡುಗರು ಫಸ್ಟ್ ನೈಟ್ರೋಜನ್ಸ್ ಇಲ್ಲಿನೂ NH2 ಇದೆ. But exactly the correct answer is third nitrogen. Why, sir? The third nitrogen containing hydrogen or third nitrogen is far away from the carbonyl carbon. ಇದರಿಂದ ದೂರವಾಗಿದೆ. Far away from the carbonyl carbon because there is no steric hindrance. ಅದೇ ಫಸ್ಟ್ ನೈಟ್ರೋಜನ್ ಯಾಕೆ ಕಂಡೆನ್ಸೇಷನ್ ಆಗಲ್ಲ ಸರ್ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ನಿಯರ್ ಟು ದಿ carbonyl carbon, the molecule undergoes steric hindrance. So semi-carbazide containing the third nitrogen only undergoes condensation. ಮತ್ತೆ ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಡಿ, semi-carbazide ಅಲ್ಲಿ 3ನೇ ನೈಟ್ರೋಜನ್ ಕಂಡೆನ್ಸೇಷನ್ ಅಲ್ಲಿ ಪಾಲ್ಗೊಳ್ಳುತ್ತೆ semi-carbazide ಚಾಪ್ಟರ್ ಅಲ್ಲಿ. ಹಾಗಾದ್ರೆ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ನಾವು ನೋಡ್ತಾ ಹೋಗೋಣ. ಎಸ್ ಸರ್, RC ಡಬಲ್ ಬಾಂಡ್ OH, ದಿಸ್ ಈಸ್ ಯುವರ್ aldehyde. ಬೇಜಾರು ಮಾಡ್ಕೋಬೇಡ್ರಿ, ಸಿಮಿಲರ್ ರಿಯಾಕ್ಷನ್ಸ್ ಕಂಟಿನ್ಯೂ ಹೋಗ್ತದೆ. ಸರ್ H2N NH C double bond O NH2. Yes, ಗೊತ್ತಿದೆ loss of water, sir. This is your loss of water. Just once you loss of water to form the compound is RCH as it is double bond N. This is your NH C double bond O. This is NH2. What is the name of compound? This is aldehyde. Semi-carbazole. When aldehyde reacts with semi-carbazide to form, the answer is aldehyde semi-carbazole. So this is your semi-carbazide. Can you practice with the examples? And now RC R double bond. Just directly I have considered next one is your ketone. Sir, what happens when ketone react with the same semi-carbazide, double bond O, this is your NH2. Sir, once undergoes, this is an elimination of water, this is a loss of water. Once a loss of water will be takes place, the answer is R, C, double bond N, this is R and C, yes, NH, C double bond O, NH. The answer is a ketone, yes, semi-carbazide. I repeat once again, friends, either aldehyde or ketone reacts with semi-carbazides to form the corresponding either aldehyde semi-carbazole or either ketone semi-carbazole. This is the fourth reaction of condensation in aldehyde as well as ketone in its corresponding chemical properties. And after this semi-carbazide reaction, we have another one more condensation reaction is mentioned in our syllabus is 2,4-DNP, 2,4-dinitrophenyl hydrazine. Yes, what happens? This DNP reacts with either aldehydes or either ketone condensation reactions. A very interesting condensation reaction as mentioned in our syllabus. To keep practicing, it's very important. 2,4-DNP. Yes, I mentioned this structure here. This is second position in O2. This is the fourth position in O2. NH and NH2. Name 2,4-DNP. Yes, what happens? Say RC double bond OH. Your aldehyde reacts with, keep practicing. Yes, this is mentioned. H2N. This is your NH. Just compare with your component. This is NO2 and this is your NO2. What its name? 2,4-DNP. What is a DNP? Dinitrophenyl hydrazine. This is your aldehyde. Aldehyde reacts with 2,4-DNP with the loss of water. This is a loss of water. The loss of water. The formation of the product is very important, friends. This is your RC double bond N NH. This is your benzene. We mention here NO2 and here also NO2. This is your H. Yes, the name of this compound aldehyde 2,4-dinitrophenyl hydrazone is the compound. I repeat, when aldehyde reacts with 2,4-DNP to form the product aldehyde 2,4-dinitrophenyl hydrazone. As similar to this, you can practice with your ketone also. Ketone allu ide ತರ reaction ಬರ್ಕೊಂತ ಹೋಗಬಹುದು. Yes, direct ಆಗಿ ನಿಮಗೆ ಬೇಕಾದ್ರೆ ಹೇಳ್ಬಿಡ್ತೇನೆ, ಇದು aldehyde. You can practice aldehyde react with DNP, aldehyde 2,4-dinitrophenyl hydrazine. ನೀವು ಇಲ್ಲಿ ಎಸ್ಟಾಲ್ಡಿಹೈಡ್ ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಫಾರ್ಮುಲಾ CH3 CHO ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ಎಸ್ಟಾಲ್ಡಿಹೈಡ್ 2,4-dinitrophenyl hydrazine ಬರ್ತದೆ ಮಕ್ಕಳೇ. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲೇ ಚೇಂಜ್ ಮಾಡಿ ತೋರಿಸ್ತೇನೆ ನಾನು. ಸರ್, this is your R. Now the product is ketone. Ketone react with DNP. Sir, this is just you have to change this R group. Now the compound is a ketone 2,4-dinitrophenyl hydrazine. So this is also the condensation reaction of the aldehydes and ketone chapter. Totally we have, friends, keep yourself the total 5 components we can use in ammonical derivatives: hydroxylamine, hydrazine, phenylhydrazine, semi-carbazide and 2,4-DNP. As among these 5, we have totally 10 reactions, 5 each for aldehyde, 5 to ketones. With examples, totally we observing 20 reaction for this condensation general with corresponding example. You keep practicing of condensation. Among these 5, they ask any one reaction for 1 mark in your annual examination. What happens? Aldehyde react with this. Answers keep ready. Hydroxylamine, oxide, hydrazine, hydrazone, phenylhydrazine, phenylhydrazone, semicarbazole, DNP, 2,4-dinitrofenylhydrazone. These are the answers for 1 mark. Keep practicing with different examples in your work. Thank you. Continue the next part in the next video. Welcome to everyone. Now we want the preparation of ketones. After completion of the preparation of aldehydes by Stephens, Yettard, Rosenman and Gutterman coach, now we have the preparation of ketones from the very important 2 reactions, one dialkyl cadmium and another one Friedel-Crafts alkylation and acylation reaction, especially acylation reaction. Now how to preparation of ketone from dialkyl cadmium. So friends, you keep in your mind is RMGX. I think all of you know this RMGX is nothing but Grignard reagent, shortcut GR. When Grignard reagent is reacted with a salt is cadmium chloride. Grignard reagent is reacted with cadmium chloride. To form the product is magnesium salt will be come out, yes, with 2 moles. Yes, this is Cl, we require 2 R. What it remains, the 2 alkyl group with cadmium, the product is R2CD. This R2CD is called dialkyl cadmium. I repeat, when Grignard reagent is reacted with cadmium chloride to form dialkyl cadmium and magnesium salt. And this dialkyl cadmium, we can use this R2CD. Dialkyl cadmium is reacted with a very important component is acid chloride. I think all of you know acid chloride. When dialkyl cadmium is reacted with acid chloride, very simply keep in your mind friends, cadmium and replace with Cl with 2 moles. Now the product is formed is a CdCl2, cadmium chloride is come out. What it remains? The 2 alkyl and 2 alkyl groups. Sir, this is an R and this is one R. 2 alkyl groups, 2 moles. With carbonate carbon, this is a C double bond O. Now this is your answer is ketone. I repeat, in Grignard reagent react with cadmium chloride to form dialkyl cadmium. When this dialkyl cadmium is reacted with acid chloride to form our ketone. If you want an example, yes, I have to use direct reaction with an example. Yes, we have a Grignard reagent CH3MgBr. Name methyl magnesium bromide. Methyl magnesium bromide reacts with your cadmium chloride, CdCl2. Cadmium chloride with 2 moles because 2Cl here is a 2 moles. Is the loss of salt with 2 moles of MgBr and this is acid. Yes, what it forms? It's easy to form the R2CD. That is R2 means CH3 is 2 moles. The compound is CH3 twice CD. CH3 twice. CH3 means dimethyl cadmium. And now this dimethyl cadmium is reacting with the second reaction. It's acid chloride. Now I can use CH3, C double bond O, Cl. What it name? Its name acetyl chloride. Acetyl chloride. With how many moles? 2 moles. Now the 2Cl is a 2 loss of CdCl. Cadmium chloride is positive. What it remains? CH3 2 times, CH3 2 times 1 ketone. And now the answer is CH3, C double bond O, CH3. How many times? 2 times. The name of this compound is acetone or 2-propanone or dimethyl ketone. This is a wonderful reaction when preparation of ketone from cadmium side. I repeat friends, when Grignard reagent reacts with cadmium chloride to form dialkyl cadmium, and then this dialkyl cadmium reacts with acidic chlorides to form ketone. This is the two important reactions of general. So I will mention in one line reaction in example. This is Grignard reagent, methyl magnesium bromide Grignard reagent react with cadmium chloride to form dimethyl cadmium. Then it react with your acidic chloride is acetyl chloride to form acetone. You can change different acidic chlorides, you can get the different corresponding ketones. This is a very helpful reaction because friends, in this reaction we can prepare similar means a symmetric ether or either asymmetric ether. ಅಂದ್ರೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ ಮಿಥೈಲ್ ತಗೊಂಡ್ರೆ ಸೇಮ್ ಬರ್ತದೆ ಮಕ್ಕಳೇ. ಇಲ್ಲಿ ಮಿಥೈಲ್ ಮೆಗ್ನೀಷಿಯಂ ಬ್ರೋಮೈಡ್, ಇಲ್ಲಿ ಈಥೈಲ್ ತಗೊಂಡ್ರೆ ಅಸಿಮೆಟ್ರಿಕ್ ಆಗ್ತದೆ. ಎಸ್ ಅಲಿಫೆಟಿಕ್ ವಿತ್ ಮಿಕ್ಸ್ ವಿತ್ ಅರೋಮೆಟಿಕ್ ಮಾಡಬಹುದು ನಾವು. ಯು ಕ್ಯಾನ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ aromatic ketones also. This is a wonderful industrial reaction, dialkyl cadmium, which can prepare ketones either symmetric or either asymmetric. We can keep practicing with different examples to prepare different ketones. And then we have another method, is a Friedel-Crafts reaction, already know, but how to prepare these ketones in your Friedel-Crafts acylation. Thank you. Welcome to everyone. Now we move on to the next preparation of ketones. The name of the reaction is a Friedel-Crafts acylation reaction. Friends, we already know Friedel-Crafts reaction we have in a reagent is anhydrous aluminum chloride, AlCl. Anhydrous aluminum chloride is a reagent we used in a Friedel-Crafts reaction in the last chapter we know, because aluminum chloride helps to generate the electrophile. What happens, sir, when this is your benzene? When benzene react with your alkyl halides, you can use any alkyl halides. Like example, this is a CH3SCl. This is your alkyl halides. When this alkyl halide undergoes react with anhydrous aluminum chloride. Anhydrous aluminum chloride to form acylation. As alkylation. In the place of this alkyl, we can use acyl groups. Like example, CH3, C double bond O, Cl. We know the name of this compound is acetyl chloride. Acetyl chloride. I repeat, benzene react with acetyl chloride in presence of anhydrous aluminum chloride. Due to this is called acylation, and this one of this hydrogen is combined with Cl to form HCl. What it remains, benzene. This is the C double bond O. This is your compound is CH2. Yes, benzene react with acetyl chloride in presence of anhydrous aluminum chloride to form this compound methyl phenyl ketone. Methyl phenyl ketone. Commonly or commercially we know this compound acetophenone. So this is very important, friends. When benzene react with acetyl chloride to form acetophenone, this is a preparation of aromatic ketones. Yes, similarly, if you practice with the same reaction, when benzene reacts with, you can change this methyl group to the ethyl group. This is a C double bond OCl. Propyl chloride, PROPEOY. Start with propyl chlorides in presence of anhydrous aluminum chloride. Same HCl is released. You can use this is your benzene. And now, friends, C double bond O. This is C2H5. Yes, benzene react with propyl chloride just to form this compound. Name of this compound ethyl phenyl. Ethyl phenyl ketone. These two are the very interesting reaction in a frill prep. Based on this, you can practice yourself in the home. Is a general reaction of acylation. Yes, can you use this is a benzene? Acid chloride formula is RC double bond OCl. This is your acid chloride. In presence of anhydrous aluminum chloride. Same friends, you can release HCl, loss of HCl. Now the product is benzene as it is. This is a C double bond ketone. This is your R. Yes, this is your aromatic. Means Friedel-Crafts acylation helps to prepare only aromatic ketones, like example acetophenone or ethyl phenyl ketone. This is your general reaction. But dialkyl cadmium can provide us to the symmetric ether, symmetric ketone, asymmetric ketone, and similarly your aliphatic ketone and aromatic ketone. Ketone can be easy to provide by dialkyl cadmium as compared with the Friedel-Crafts reaction, friends. Friedel-Crafts helps us to only aromatic ketones like acetophenone. This is one of the best wonderful reaction. We already know in PUC first year electrophilic substitution reaction. PUC first year electrophilic substitution reaction band hogide makle. This is the very simplest reaction of our syllabus. Yes, this is the preparations of ketones, and then in the next video we move on to the chemical properties of both aldehydes and ketones. Thank you so much. Hello everyone, now we have a very important reaction of this chapter is addition reactions in either aldehyde or ketone. So what happens when aldehyde and ketones react? Addition with hydrocyanic acid. HCl means hydrogen cyanide or either hydrocyanic acid. So we have a very simple reaction. This is your simple addition reaction. Just add to the aldehyde. When aldehyde is react with HCl, hydrogen cyanide, this is your aldehyde. React with hydrogen cyanide. Yes, this is very simple, friends. This pi bond is cleavage. This H plus and Cl minus, this O minus, this H is attached here, cyanide comes here. Then our product is becomes to the RCH as it is. This is OH and this is your Cl. Name of this compound aldehyde cyanohydrin. I repeat, when aldehyde react with hydrogen cyanide, to form the addition product is called aldehyde cyanohydrin. It means, yes, ketones, we can use this is your ketone, RC double bond O, this is your R. If you use ketone, then also it gives the same product when it reacts with hydrogen cyanide. Pi bond cleavage is H plus and OH minus, Cn minus. Yes, now the attachment will takes place. This is also RC. This is your alkyl R, OH, and this is your Cn. I think yourself you can provide the answer is ketone cyanohydrin. It's a very simple addition reaction, friends. When aldehyde or either ketone react with hydrocyanic acid to form the corresponding answer aldehyde cyanohydrin or either ketone cyanohydrin. If you use acetaldehyde here to form acetaldehyde cyanohydrin, use ketone, that is acetone, to form the answer is acetone cyanohydrin. This is the two simplest reaction as mentioned our syllabus. If you use corresponding example for each one, example so the first one as in the aldehyde is CH3 C double bond OH. Yes, acetaldehyde. When acetaldehyde is reacting with HCl, direct addition, I think all of you easy to write. HCl will birth. So the answer is CH3 CH. This is OH and this is your Cl. Can you give the name? Acetaldehyde cyanohydrate. Acetaldehyde cyanohydrate. Similarly to the ketone, CH3, CH3, double bond O, acetone. When this acetone undergoes react with hydrocyanic acid, the cleavage of this pi bond. And now this is the CH3, CCH3. Yes, this becomes to the OH. And now this is the final answer is acetone cyanohydrate. Yes, friends, it's a very simple addition reaction of aldehyde chapter. We have the first start with hydrocyanic acid. Either aldehyde or either ketone react with hydrogen cyanide to form corresponding cyanohydrines. Like example, acetaldehyde gives us acetaldehyde cyanohydrin and acetone gives us acetone cyanohydrins. You can practice with different aldehyde, benzaldehyde, yes, propanaldehyde, yes, you can use any aldehydes, gives us to the corresponding cyanohydrins. But in ketones, similarly, any ketones, either aliphatic or aromatic, acetone or either acetophenone, you can give the answer acetone cyanohydrin or acetophenone cyanohydrin. These are the two simplest reactions we can use for the hydrogen cyanide. But in our syllabus, they mention totally 5 mechanisms. There's 2 from haloalkene yellowarines, they named SN1 and SN2, and another 2 reactions in the alcohol chapter, hydration and dehydration, and one more, this is addition of hydrogen cyanide mechanism in the chapter aldehyde, or either addition reaction of hydrogen cyanide with your carbonyl carbon, they mention in the syllabus for mechanism. Yes, this mechanism we continue in this class. We have very simplest reaction to your mechanism. Yes, in this mechanism we have 2 steps. The first step is a slow step or either a rate determination step. Yes, in this reaction, this hydrocyanic acid HCl is react with OH minus to form as a Cl minus and to release the form and a bond. Yes, here friends, the carbonyl carbon in the step 1. Yes, slow step. Here this carbonyl carbon, this is an C double bond O, is react with Cl minus with cleavage of this pi bond to form the product C. This is a O minus, this is a Cl, to form an intermediate alkoxide, to form an alkoxide ion. And in the second step, this is in step 2, it's a fast step, the attacking of H plus ion. This is an attacking of H plus ion. Yes, this is a carbonyl carbon which already attacking the O minus, and this is a Cl, alkoxide ion. When this alkoxide ion is attacked with the proton H plus, this H is attaching to the alkoxide. Now the compound is COH and this is your Cl, the corresponding cyanohydrin, either aldehyde or either it is a very simple mechanism. Yes, when either aldehyde or ketone or either carbonyl carbon is undergoes addition with hydrogen cyanide to form, in the first step is alkoxide ion, in the second step is cyanohydrin. This is a simple mechanism. Yes, we continue this mechanism once again with corresponding example in the next video. Okay, as you keep practicing, this much is enough for examination, but you need an examples of aldehydes or ketones we will discuss in the next video. Thank you.